Let's keep going with some more probabilities here. I wanted to do a couple more experiments, and we'll sort of also bring in this idea of a percent chance, which is essentially just a probability converted into a percentage, right? A probability is kind of the natural form here is going to be as a fraction. So in theory, any of those can be converted into percentages, and that would be our percent chance. So let's set one up, and I'm going to on purpose try to set us up one with with one that has some nice conversions. So let's do an experiment where we roll a 10-sided dice, right? So not the standard, just like 1, 2, 3, 4, 5, 6, not the standard cube. This would have to have a little bit of a different shape where you have 10 kind of equally likely sides, 10 equally, 10 equal sides, so they're all just as likely to be landed on. So the numbers here, right, the possible outcomes would just be the digits 1 through 10. And so then our probability, right? So what is probability of rolling, let's say, a multiple of 3? So multiples of 3, right? So the outcomes there would be 3 or 6 or 9. So that's sort of 3 possible successes, out of 10 total. So our probability here would be 3 out of 10. And what we can do is convert into a percent chance. So that's literally just going to be, right, the same percent conversion we did way back in 7.1, way back, last week. Whatever, not that long ago. So to do that, what we're going to do is, right, just multiply essentially by 100%, right? And so for us, this is an extremely fast and easy conversion. 3 out of 10, I'm sure you're yelling at the screen saying, I don't need to see this. I know it's 30%, right? 3 out of 10 is sort of clearly 30%. So that would be our 30% chance. Right, so we're just sort of counting up all the possible ways to hit a multiple of 3, 3, 6, 9, right? There are 3 of those possibilities, and so that's the number that ends up top, right? It's not that this is a multiple of 3 and this is 3. That's kind of just a coincidence, really, more than anything else. You could also say, what's the probability of right, rolling an even number, right? So your successes, your kind of outcomes there, 2, 4, 6, 8, and 10, right? So that's 5 possible successes. So your probability, of course, 5 out of 10. And then as a percent chance, right, converted, that 5 out of 10 would, of course, just be 50%. Right, so pretty classic. You can sort of do variations here and get slightly more interesting examples if you, use a bigger dice, right? If we jump from a 10-sided to 20-sided or even higher. I think I goofily asked a class one time, could you have a 100-sided dice? What would it even look like? And, I think there were ones you get stuff that just starts to look like a golf ball or whatever, right? It's just little dimples or something like that. Essentially almost looks like a circle at that point. Let's do a different scenario, right? Let's say we have a bag of marbles with, different colors, right? So let's say there are 3 reds, there are 6 green, and there are 6 blue. So this is, in a cloth bag or something, right, where we can't see what we're picking. And so we're just going to pick one and see what we get. So the question would be, what is the probability of picking a red marble, right? So what would the answer there be? So I know that there are 3 red marbles. What's the sort of total number here? So this would be, right, kind of out of 3 plus 6 is 15 total marbles. So your probability in this case becomes 3 out of 15. That would reduce, right? That would reduce down to 1/5. So our probability is a fraction. That's when we can convert into a percent chance, right? 1/5 times a 100% would get us to 20%. So we have a 20% chance of picking a red out of this bag where we've got 3 reds, 6 greens, and 6 blues. Let's run another experiment. What about, what is probability of picking, what should we do? We can change this up a little bit, how we're asking it. Oh, I tell you what, I'm going to change the way I'm asking this a little bit. What is the probability of not picking a green marble, right? So there are different ways to ask some of these questions, right? So you can obviously say, you know, what about the probability, right, of picking a red versus picking a green versus picking a blue? You can imagine, right, green and blue are just going to be 6/15 and 6/15 respectively, right? We can ask this a little bit of a different way. So what's the probability of not picking a particular color? So not picking a green. So how do I not pick a green? That would mean I would need to have picked either red or blue. There were 3 reds and there were 6 blues, right? 3 reds, 6 greens, 6 blue. So if I'm not picking a green, it has to be either red or blue. So that is 9 possibles, right, out of 15 total. So your probability becomes 9 out of 15. This would reduce again, right? Everything here is divisible by 3. So that's going to reduce to 3 out of 5. So that's our probability. Converted into a percent chance, right? 3 out of 5 times 100% would be a 60% chance. Sometimes if you ask questions, right, that sort of use this sort of not framing, that's sometimes referred to as a complement, right? Meaning it sort of is an opposite kind of thing. So you could actually do a probability of picking a green, which would be 6 out of 15. And then what you do is you would subtract that probability away from 1, right? So you're sort of saying, what is the probability of this thing not happening is the same thing as sort of the opposite of the probability that it does happen. So if you're working out of 100%, right, sort of one whole being the sort of total universe, if you're looking for the opposite of a probability, sometimes it's easier to figure out the probability itself and then do kind of a 1 minus that value and sort of end up with the opposite. So we could have done that here, or we can kind of just do it directly in this case. If we have a simple enough situation where it's like, I could do red and blue together, that's really not a big ask. So that's some of the basics. I'm going to do one more video where we dig in a little bit onto these, pick a card, any card from a deck of card probabilities. I just want to make sure we take a minute and lay out, what a deck of card looks like before we go into those. So we'll do one last video here about cards, but this is, this is how it goes.